Hi, my name is Oktay. Welcome to today's video about extraterrestrial life and the chances for alien life. This is a nice artist's image of aliens. This is how we want them to be: friendly, sociable, intelligent, curious, communicative. But what is the probability for extraterrestrial life? This is how the universe began with the Big Bang 13.8 billion years ago. This is the beginning of matter, time, and space as we know it. There was just a short period of 20 minutes for the nucleosynthesis of the elements. Because of the beryllium barrier, after 20 minutes there were only the elements hydrogen, helium, and lithium. And this is thought to be the first molecule ever in the universe. That's helium hydride. This is a high energy compound. Later, when the universe cooled down, normal hydrogen, H2, was formed, and lithium gas contains 1% of dilithium. But with these three elements, you can't start life. For this, you need another step. That's a supernova. There's another artist concept of a B-type star. They have typically the mass of 2 to 16 times their sun's mass. The lifespan is in the millions of years. So 1 or 2 billion years after the Big Bang, the metallicity was already significantly higher, because several generations of these massive stars, and their supernovas produced other elements that are required for life. This is a beautiful render of the Milky Way galaxy. Its size is 100,000 light years. This is how an extragalactic observer would see the Milky Way galaxy. This is a spiral bar galaxy. The Sun is located here at a distance of 26,000 light years from the center. You can see nicely this bar and the main spiral arms. The Sun is located in a minor arm in the Orion spur. But the formation of the solar system happened 9.2 billion years after the Big Bang. So was really Earth the first habitable planet ever in the Milky Way galaxy? And in my opinion, that's very unlikely. There's one number that is not a proof, but it's, in my opinion, a strong hint that there should be more habitable worlds than Earth. This is an overview of all the exoplanets and the habitable zones of other stars that were found in recent years. The Kepler mission and the follow-up missions were a great scientific success. Now we know there are 5 billion Earth-sized planets in the habitable zone of G-type stars in the Milky Way. Here you can see the 3 most common types of stars. Number 1, by abundance, is 75% the red dwarfs, M stars. Number 2, A stars, orange dwarfs, with 12%. And sun-like stars are the G stars, with 8%. And it could be that K stars also support Earth-sized planets that are habitable. This would add at least another 5 billion Earth-sized planets that are potentially habitable. I made another video about planet Earth. It's called Life Planet Earth. Planet Earth is really special because it has a combination of several features that enabled life. It is in the habitable zone of the Sun. It has a global magnetic field which reduces the atmospheric loss to a minimum. It has plate tectonics and volcanism. These two phenomena bring fresh minerals from inner Earth to the surface. There's a big advantage for life. It has a big moon that stabilizes the climate. Then traces of 423 parts per million CO2. CO2 is an essential molecule for life, as same as water. It is essential because it delivers the greenhouse effect, and it is needed for the photosynthesis reaction. And the effect of the CO2 makes liquid water possible, and water covers 71% of Earth's surface. This is an artist's concept of how an ocean planet would look like. These are the 5 most common elements in the universe. Number 1, hydrogen. Number 2, helium. Number 3, oxygen. Number 4, carbon. Number 5, neon. So in the interstellar gas, there's a lot of water that's very abundant in the universe. But still, you need a delivery system that brings the water to the planets. And on Earth, there are 2 systems. One is Jupiter with its slightly eccentric orbit. It reflected several big planetesimals which were water-rich into the inner solar system. Some of them crashed into Earth, brought the water. Second mechanism is the chemical reaction of the oxide from the dust disk that lasted for several million years after during the formation of the solar system. It's the hydrogen from the stellar wind that produces also water. This is an example of a planetary system in the making. That's AS209. This is a picture from the Atacama Large Millimeter Array ALMA telescope. This star is a K-star. It's slightly less massive than the Sun. It's located at a distance of 410 light years. Its age is 500,000 to 1 million years. And you can see a dust disk with gaps. And what is interesting about this planet is as a gas giant, it's a mass of 20% of Jupiter, but it's at a distance of 95 AU, which is at a very big distance. 1 AU is an Earth-Sun distance of 150 million kilometers. These are some potential worlds where there's water. These are, of course, just computer renders. At the left, that's Kepler 22b, and Kepler 69c, Kepler 452b, 62f, Kepler 186f, and for comparison at the right, that's planet Earth. These are other potentially habitable worlds, but in our own solar system. At the left, that's Mars. And next to it, it's Europa, Jupiter moon. Enceladus is moon of Saturn. And another potential world is Titan, the biggest moon of planet Saturn. And all these worlds could also have life, but it's probably simple life, and it's under the surface because the surface is exposed to the hard radiation from the sun. This was a one-time event in 1977. That was the wow signal. It was a 72 seconds signal, and its origin is unclear. It could be from the Sagittarius constellation. This is the Drake equation. It tries to calculate the number n, which is the number of active communicative extraterrestrial civilizations in our galaxy Milky Way. And you can see all these factors. Some of them are very well known. Some of them are not known at all. For example, this R star is the star formation rate, which is about 1 to 3 solar masses are converted to stars per year in the Milky Way. FP is this fraction of stars with planets. That was a big success of the Kepler mission. Now we know 1/6 of G stars have planets, the size of the Earth at the right distance. And E is the fraction of planets that support life. We have no idea yet of this factor, but the James Webb Space Telescope is capable of giving us a number because it can take a factor from all these planets. And it has already, we have already found something, for example, about the planet TRAPPIST-1c. FL is the fraction of planets that develop life. FI is the fraction of planets that develop intelligent life. FC is the fraction of civilizations that develop communication technologies, and L is the length of the time for detectable signals in space. And the estimations for this number n, they are in the worst case in the thousands, and in the best case in the millions. This is an unusual system. It was found by direct imaging. That's HR8799. It's located at a distance of 133 light years. It's a bigger version of the solar system. The star is bigger, has 1.4 times the sun's mass, and is a very young system at the age of just 30 million years. It contains 4 super Jupiters. They have a mass of 6 to 9 Jupiter masses, and it could be that not only planets but also moons can support life, because it is there's a good chance that these massive Jupiter-like planets have moons that are much bigger than all the moons in our solar system. This is an artist's image of how a view from a potential exomoon would look like. This is an image of the exoplanet Pix, which is also, as the name, BD plus 1444599b. This is an artist's image of the closest exoplanet to the solar system, that's Proxima b. This is at a distance of just 4.2 light years. This is how it could look like in the best case. Proxima Centauri is another type of star. It's a low-mass M-dwarf, red dwarf star. It is likely that this planet is tidally locked to its star. So the sun is always at the same place in the sky. And in the background you can see the other two bigger stars of the system, Alpha Centauri. So the night side is all the time in the dark. If this kind of planet has life, then it's very likely to be different than the life that we know, because, for example, a molecule like chlorophyll would not work optimal in this environment. And I think that if there's life on this planet, nature would find another way to convert the light of this different type of star. This is another very interesting, nice drawing of aliens. I will put the links of these images into the description field. And that was today's video about alien life and chances of extraterrestrial life. Thank you for watching. Have a nice day. Bye-bye.